Thank you. Thank you. So this talk is about, does your code measure up? It's about static analysis and other things. It's kind of a good follow-up to what Josh was just talking about, where he's talking about logs and things like that. This is your application before you get to that point, right? So these are measuring the tools, or different tools and things to measure that. Let me just reset here. There we go. So I'm not going to really do much of an intro. If you don't know who I am, you can figure it out from some of the other talks. But anyway, so one of the things with this talk is measuring the code quality and measuring your application. How many bugs are in your application? How many problems you have? If you're doing it this way, you've got a problem. You really shouldn't be measuring it by the amount of people asking, what's going on with the code. But as we're going through and we're using our applications and we're measuring them, it's really easy because most of us, as we're looking at our application or as we're experiencing our application, it's similar to listening to music, right? We can listen to music and we know when music is bad. You can listen to a song and say, "Ah, man, that's just horrible. I hate listening to it." But with code, it's not necessarily so straightforward. You can't just necessarily look at code and tell that it's bad. Now, if it's really bad, you can. But generally speaking, we don't know if it's really bad just at a glance. So we need to be able to measure it in a more quantifiable way. We have to be able to look at our code through the eyes of some of the tools that are out there and gain some true insight of, is it really bad? And if it is really bad, how can I fix it? Right? Because just because a tool tells you that the code is bad, if it doesn't give you any insight of how to fix it, you're not really going to be able to work much with it. So we want to make sure that we're able to measure. We want to make sure that we're able to accurately quantify the issues inside of our code. We want charts, we want graphs, we want all these good things. But why do we measure? So we measure because we want to highlight the bugs that are in our code. We want to know if there are any bugs in the code, if they're causing any issues. We want to know that. We want to be able to look at them a little bit more detailed. We also want to improve the quality of our code in our applications. This plays a direct role in onboarding new developers. If you have an application and it's really buggy and you're really having difficulties with it, it's very hard to hire new developers and put them into the application. We've all been hired at some point in our careers by a company where the code necessarily wasn't that great. And so you start work with the employer and you have to wait 2, 3, maybe even 4 weeks before you gain enough insight to the application to be able to be productive. And that's not a good thing. If a company is hiring somebody and it's taking a few weeks for them to become productive, there's obviously a problem there. The quality of the code, the quality of the application plays a direct role in that. We want to be able to get people that we hire productive really fast. We want them to be able to start getting into the code and start being productive, almost immediately. We as developers spend most of our time reading code and very little of our time actually writing code. You can't add new functionality without looking at the application first. You can't tell, okay, where am I going to add this feature without looking at the surrounding code. We have to do a lot of reading. The number that I use is about 70 to 75% of our time is spent reading code. The rest of it is actually spent writing. Well, imagine if the quality of the code was high enough so you could reduce the amount of time you have to actually read the code. Then you're spending a lot more time actually being productive, because now you don't have to read quite so much. You can have coding standards in place, so it makes the code easier to read. You can have set practices in way. This is the way we're going to name our variables. This is the way we're going to name our classes and so forth. So that way we're able to be productive a lot faster as well. It also makes the code more testable, because if the code is easier to read and it's easier to know what's going on, it's also easier to create tests to be able to properly test the code. Now, if we have all this, if we have improved quality, another reason to measure would be so that we have satisfied customers. Because obviously, if we're able to onboard developers much faster, if we're able to create code faster, if we're spending less time reading and more time creating, we're going to have happier customers. They're going to get features faster. They're going to have faster development times for that. They're also going to have less broken features as we're working on the application. Because of the quality of the code, it's just going to make things better all the way around. There's also a little bit of personal pride in there. You know, if you write some code and you know that it's high quality, you just feel better about what you're doing. You feel better about your job on a day-to-day. If you're working in an application and the code quality is very bad and you know it, you know, maybe you inherited some code or something like that. You don't really feel good about your job. You don't really feel good about your day-to-day, especially if you're the one creating the bad code. You really feel bad internally. We can't help it. It's our nature that we don't feel good about it. And because of all this, of course, that can lead to higher salaries, right? That's another reason to measure. Because if we're writing better applications, if we're able to create features faster, we can demand higher salaries because now we're able to be more productive for our customers. So what are some of the things that we should measure? Well, one of those is cyclomatic complexity. Who doesn't know what cyclomatic complexity is? Okay, we have a few out there. Cyclomatic complexity is the number of decision points within your code. It's the number of decision points in the code. According to Wikipedia, it's the count of the number of linearly independent paths through the source code. So it's the decision points. Now, as kind of a base rule, we try to keep that less than 10. Now, what does that mean? What that means is if you have a function and you have a couple of if statements there, so a function counts as one just by itself, right? Because you have one path through the source code. If you have a couple of if statements, each if statement counts as one. So right here, this would count as 3. Because you have one for your function and one for each of the if statements. So the cyclomatic complexity of this function is 3. Again, the goal is to be less than 10. My personal goal is much less than that. I try to keep my cyclomatic complexity around 4 or 5. Anything higher than that I consider extreme. Now keep in mind also that a function is really only meant to do one thing. So we can make it a lot simpler through that. If your function is only doing one thing, how many cyclomatic complexity points do you really need to do one thing? So that's cyclomatic complexity. That's one of the things that we want to measure. Another thing we want to measure is duplicate code. We want to measure duplicate code. This is where code was copied from one place and pasted into another, a direct clone, right? We want to keep that minimal. There's a thing out there called the rule of 3. I don't know who actually really created it, but I know most of the Martin Fowler and Uncle Bob Martin talk about it, the rule of 3, where basically what it says is if you copy code and paste it to another place once, it's probably okay. You're only doing it once. If you do it a second time, you kind of wince a little bit, but you still do it anyway because you're busy, you're getting things done. But if you're having to copy and paste it a third time, then you should definitely refactor that, create a function or some way to normalize that so that way you're not actually creating duplicate code in more places. So the rule of 3 is a good rule of thumb to go by. So that's duplicate code. That's another thing that we should measure. Long classes. We should measure the length of our classes. Now, if you're creating methods and you keep your methods nice and short, keep your functions nice and short because they only do one thing, your classes will also end up being quite short. Because a class should solve a problem. It solves one problem. Now, each method within that class, a class solves a problem. A method does one thing towards solving that problem, but a class only solves one problem. So you really don't need a lot of lines of code for that. As a threshold, by default, using some of the static analysis tools, you'll find that they use 1,000 lines of code as a guide. You can tweak that as you need to, but long classes is another thing we want to look at to see, where we might have some problems. These are code smells. We're going to talk a little bit more about those as we go by. We also want to take a look at the class complexity. Now, this is a cyclomatic complexity we were already talking about. And the cyclomatic complexity, remember, we try to keep those nice and low. I personally try to keep my functions around 4 or 5 cyclomatic complexity. So if your class has a certain number of functions within it, obviously you want to keep that. The cyclomatic complexity is going to carry through to the entire class. So we want to keep that less than 50. So if we're going for, a 10 cyclomatic complexity in our functions, this would kind of indicate maybe we're only going to do 5 functions in a class. But again, it all depends on what you need. Again, a class is solving a problem, and a method is taking care of one thing towards solving that problem. Long methods are another thing we want to look at, kind of what I was already talking about, right? Where our methods really aren't going to be very long because a method is only solving one thing, or doing one thing. It's only doing one thing. So if it's doing one thing, you don't really need a lot of lines of code to do that. It shouldn't take a lot of lines of code to do one thing. Unused variables, where maybe you created a temporary variable and you were using it in your code. You've cleaned that up or refactored at some point or another, and now you have a variable just kind of hanging out there and not really doing anything. So we want to make sure we're tracking unused variables. We want to make sure we're also looking at unused other things as well. Unused classes, unused functions, unused variables, unused constants. Anything that is unused, we want to clean that up. So we want to measure those things that are not used anymore. Or maybe they were never used. Maybe we created them during development time and then we ended up not using them. Lack or overuse of comments. So comments are a code smell as well. Now, I'm not saying don't add comments to your code. That is wrong. I'm not saying that at all. But what I'm saying is we want to make sure that the comments aren't extreme. We want to make sure that comments are clear, they are concise, and they're not explaining bad code. If you're creating comments for the sake of explaining code, you're doing it wrong. Your code shouldn't be so complex that you need to explain it. If you have to explain it, then there's problems there. As an example, I don't know if you're going to be able to read this or not, but I use this example quite often. I have an if statement here where the first part of this if statement we're checking an employee's flags to make sure that it's set. We're also looking to see if there's an hourly flag set. And then we're also looking at the employee age to see if it's larger than 65. Now, the comment above that is check to see if the employee is eligible for full-time benefits, for full benefits. Alternatively, we could have refactored that, right? We could have created a function and named it something meaningful, like is eligible for full-time benefits. Do we really need a comment for that anymore? We did obviously need a comment here because we had like 3 or 4 different conditions going on there in one if statement, which is just a nightmare. But if we move those conditions to the function and name the function appropriately, we can kind of get away without doing a comment on that. It's kind of self-documenting. Don't get me wrong, I'm not saying that code should be self-documenting. It should be closer to self-document, but there's no such thing as self-documenting code. It just doesn't happen. It's good to make the code as descriptive as you can, but there's no such thing as self-documenting code. We still need comments. Now, generally the way that I use comments is, take this good or bad, but the way that I use comments is I use it to explain the intent of the code sometimes. Sometimes I want to explain, this is why I did this. Maybe there was some business decision or something, so somebody in the future can look at it and say, why the hell did Adam do that, right? They can look and now they'll know why I did that, or they'll see the intent of the code. Maybe I planned on it outputting something. Now, your tests should also explain your code. A lot of times, you might not even need to put a comment if you have tests, because then they don't need a comment to explain the intent of the code. The test will do that. All right? So there's multiple ways that we can handle this without adding comments. Again, please put comments in your code. Please comment your code, but do it in a clear, concise way, and don't overdo it. As a general rule, I'm going to show a tool here in just a little bit called PHP Lines of Code, LOC, PHP Lock. And it tells you how, the lines of code. It also tells you the lines of comments within the code. I generally aim for about a 25%, application-wide. I keep hearing my own breath through this microphone. It's bothering me. All right, also we want to measure heavy global usage. Now, I say heavy global usage, but I want to measure all the global usage because I don't want to use globals. I don't use globals in my code, and you shouldn't either. Globals are kind of a pitfall. If you have the global keyword being used anywhere in your code, you should clean that up. That should not be in your code anywhere. Clean it up. Now, there are other super globals. It's okay to use those. But I would encourage you to abstract those out versus using them over and over again. Clean them up and make them a lot better and protect yourself against them. Because generally, your super globals are going to be generally brought in from a user somehow. So you want to make sure you clean those up and you're not using them in a naked way. We also want to make sure that we're checking end-path complexity. Who doesn't know what end-path complexity is? I'll probably see a lot more hands on that. Wow, I'm not. I'm actually seeing less hands for that than Cyclomatic. Wow, that's amazing. End-path complexity is the number of paths through the source code. This is the number of possible outcomes of the source code. Much different than cyclomatic complexity. Cyclomatic complexity is the amount of decision points. This is different than that. This is the number of possible outcomes of the code. And it could be very high. I'm a consultant, and we're often approached by companies that ask us to do audits of their code. Can you tell us the quality of the code? And, it amazes me. I'll see functions that go up in the trillions of end-path complexity. It's a nightmare in some cases. And, once we clean that up, usually it's just some small decision point that was doing some form of reflection or something goofy where it really wasn't warranted. And it really boosted the end-path complexity. We clean that up, and all of a sudden their code is loading in less than a second instead of the multiple seconds that it was taking. And it can really help things out. It can really make things better. There's a lot more things that we can measure. Ultimately, we want to measure all the code smells. Those are some of the important ones, the ones that I just highlighted. But there are other things that we want to measure as well. There's a lot of different code smells out there. Some of them I already hit on. Duplicate code, long methods, large classes, long parameter lists. I didn't mention that one, but that one's an important one too. Now, what I mean by this is the number of arguments you pass into a function, right? Well, if your function is only doing one thing, how many arguments do you need for that? Generally, you don't need many. You need very, very few. Maybe one or two or three is extreme, in my opinion. If your function needs more than that, I would encourage you to create some sort of factory or something like that to handle it and then pass in the object instead of a bunch of arguments. But that's a different matter. We also want to look for switch statements. That's a code smell. Generally, you're sacrificing polymorphism by using a switch statement. Not always. I'm not saying switch statements are bad. Keep in mind, these are code smells. These are not saying that these things are bad. It is saying that they are a smell and might potentially highlight something else that's wrong, right? So we want to use these as indicators. It doesn't mean they're bad. Switch statements are not bad. Well, long parameter list, I always consider that bad. But anyway, these are just smells. We want to try to stay away from them. And they also highlight where there might be other problems. Temporary fields or variables are a code smell. That doesn't mean don't use temporary variables. It just means make them earn their keep, right? If you're using a temporary variable and you're only using it in one place, you don't need that temporary variable. It's only being used once. Instead, just call whatever you're doing. Again, comments hit on that. Now, some of the tools that I use for this are available at PHP QA Tools, which has been deprecated. PHP QA Tools was a website that was maintained by Sebastian Bergman, and he kind of grouped together some things. It's been deprecated because now there's actually a better list out there. Exacat out on github.com has a list of PHP static analysis tools. I'm going to highlight some different tools But you can go out to that list on GitHub, and there is a full list of all kinds of things to test with. I can't possibly show them all, and I can't possibly say one is better than another. There's a lot of good tools out there. I'd encourage you to check out this GitHub repo and see all the tools that are out there. One of the number one tools that I use is generally, I'm going to tell you some of the secrets of what I do on a daily basis. So again, I work at RogueWave as a consultant, and we have customers contact us and ask us, can you tell us, or help us with our code? Sometimes it's not necessarily helping them through static analysis, but they say, hey, we'd like you to come out and help us re-architect our application, help us rebuild it, rewrite it in some cases. Or they think they're going to rewrite it until they hire me, and I tell them, no, we're not going to rewrite it, we're going to refactor it. But I need to know how can I possibly quote this, right? I don't even know how much code they have. They're just contacting me through email, contacting us through our contact forms. So what I do first, my first tool is PHP Lock. This tool is really nice. You can execute it really simply, and it gives you back a nice, concise report of how many lines of code you have, how many of those are comments, how many classes exist, how many globals are being used, how many namespaces exist. There's a lot of good usable information in this report. It's really easy to run. Basically, I'm calling it via PHP. I'm calling the PHP Lock.far file. Now, you can download these and actually execute them as an application, but using them as a far is a lot easier. I'm telling it to be verbose. I'm telling it to look at all files that end in .php. I could give it other extensions as well. Generally, I only do .php. And then I'm telling it to exclude certain directories. Now, in legacy applications, I might have to do exclude multiple times. But generally speaking, I'm going to exclude the vendor directory. I don't care how many lines of code are in third-party applications. I only care how many lines of code are in the customer's application, right? So that's why I want to exclude the vendor directory. And then I'm telling it where my project is, and I'm telling it to output that to a text file. If you don't output it to a text file, and all I'm doing is just passing it straight through to a text file, it'll output it on the screen. Right? And if that's all you want, that's fine. You don't have to output it to a text file. But generally, I'm telling the customer to run this because I need to know what code they have. At this point, I don't have an NDA, right? They've just contacted us. Can you help us? I don't have an NDA, but yet I need some insight into their application so I can best, know how I'm going to help them. And then it prints out a report like this. It's not important that you see the contents of this. Just know that it's a very short report. And it just has lines that basically tell you all these statistics that I need. Off of this report, I can tell a lot about the application just off of these numbers. I don't have time to go through my translation of all this here. I can have a conversation with anybody offline if you want. But generally, I can look at this, and in about 15 minutes, I can pretty much know the mess that I'm going to get into, right? Because it is going to be a mess. They're hiring me for a reason, right? They're calling me in for a reason. They already know they have a mess. They just don't know how bad. I can usually tell based on this how deep in I'm going to get. But this is a good report, and it's good for you to know it as well. We should all keep track of our application as we're developing. How many lines of code is my application? How are my comments doing? Do I have any other issues? Now, after I finish this, if I needed deeper insight, usually my next thing is, okay, I need you to give me access to your code, so I can dig deeper than this. It's the next step is either we've already signed an NDA, or they're just willing to give me a little bit more access. Then I run what we call a PDepend. This gives you the dependencies within the application. Running the PDepend, again, it's run via the command line PHP. I'm calling pdepend.far. I'm telling it to ignore the vendor directory. I'm outputting an XML file with all the results of the tool. I'm also printing out some charts. Like Josh said earlier, charts are amazing. You can tell a lot of information from a chart. So we want to output a chart that tells me the dependencies, and I'm going to output a pyramid that shows a little bit more details about what's going on there. Now, and then I'm going to tell it the path to the project. Now, by getting the output of this, it kind of looks like this, right? So we have a little dot chart here. We want everything to be up in the top right. That's the good zone. And then on the pyramid, it has a lot of numbers there. I could spend the next hour just talking about those numbers. There's a lot of good things there. However, as I showed on the previous slide, at PDepend.org is where you can find that information. PDepend.org is what gives you all the statistics of what each of those numbers mean and what that chart means. So it's a very good resource for giving that information of how these break down. And again, it helps you know how abstracted your application is and how dependent different classes are upon each other. And it really will give you a good solid benchmark of how stable is my application. And looking at this, if I look at this and I see that everything is pretty much on the bottom left, my very next statement to the customer is, wow, it's taking you guys a long time to create new features, right? Of course, they say yes. So that's why. Because you have a lot of complexity, you have a lot of dependencies going on there, especially when you have a big dot on the left-hand side. When you have a big dot, that means you have one object that is being overused because it's up there. It's being overused quite a bit. Now, it's okay that it's toward the top. That makes it a little bit more stable, but it's not very abstract. So that's what that means. Another tool that I look at is CopyPaste. Again, CopyPaste. How many times did we copy something from one place and paste it into another? This report takes a long time to run, and it takes a lot of memory. So you really want to open up PHP at this point and say, okay, just run with it. I know you're just going to, the test is just going to run, open everything up. So we do that again, calling a FAR file, PHP CPD for CopyPaste detector.far. We're telling it the path to the project. We're excluding the vendor directory. I don't care if there's copy and paste in third-party libraries. Maybe I want to measure that once, but I don't need to do it on a regular basis. And I'm outputting the results to a text file in this case. And that looks something like this. It tells you how many matches it found, and it's going to go a line at a time through your code. It's going to look at a line, then it's going to look through the rest of the code base to see if it's copied somewhere. It's going to look at the next line, look at the rest of the code base, see if it exists somewhere. And it's going to do that for the entire code base. And that's why it uses a lot of memory, and it takes a long time to do it. And it's going to tell you line number 1, line number 2, these are copies of each other. And then it's going to tell you the amount of duplicate lines within the code base as a percentage, and how many lines that exist. And it tells you how long it took to run the test and how much memory it used to run the test. Again, this is a very condensed version. Generally, this is going to be larger, especially for a legacy application. But it's good to know that, because now you know where you need to go refactor. Now you know when you've broken the rule of 3 and you need to go create a function somewhere or something along these lines. Another very good tool is PHP Mess Detector. Now, PHP Mess Detector has multiple rule sets that you can run with it. The number one that I love the most is code size. I love code size. Code size tells us the cyclomatic complexity, the end-path complexity. It tells me the number of lines of code in a class, the number of lines of code in the functions. It tells me all these things. Code size, anything related to size within the application. I want to know all that, right? So we call it as phpmd.far. We tell it the path to the project. The next one we're doing here is I'm putting XML, because I want it to give me XML output. You can do it as text output. I want XML. XML is a little bit more readable for this report, and I'll show you in just a moment. I'm telling it code size, because that's the rule set that I want Mess Detector to use for this run. I'm telling it to exclude the vendor directory. I'm telling it to output the rule file to an XML file. And that looks kind of like this. Now, again, it's not important that we know or are able to see everything on here. There's a lot of good detail. But basically, it's going to tell you a name of a file, Where do I got a file name on here? Yeah, so we have I don't have a name of a file in this screenshot. So it's going to give you the name of the file, and then it's going to give you all the results of that file. Now, it's not going to tell you that for files that don't have an issue. So any lines in this file, they're issues. They're things that need fixed. They're things that are definitely code smells. They are obviously breaking some rule somewhere. One of the things we see here is like excessive class complexity. Here we have a class with a complexity of 143. That's a very high cyclomatic complexity for a class, right? It tells you that the rule for that is we set the threshold at 50 and it's 143. And you might see other things like an NPath complexity in millions or thousands or hundreds of thousands, things like that. But anyway, this is a good report. I generally view this in some sort of text editor. You can parse it if you wanted to, and you could add it to a database or a ticketing system. I recently had a customer that ran this report, and they wanted to clean up all their code base. And this report had thousands and thousands of lines. It was a big application. It was about 4.5 million lines of code in their application. They ran this, and after they ran it, they parsed it into their ticketing system. They said, we want to create a ticket for every problem in here. It ended up being like 1,124 files that they need to update, right? So that there was a lot of tickets. But needless to say, it made it easy for them to go back through and then edit their code and fix it. And they did. But again, it's XML, so it is really readable. Another good one is Unused. Another filter to use with PHP Mess Detector is Unused. Unused allows you to see unused things in your code, unused variable names, unused classes, unused. It doesn't tell you unused files, but it does tell you unused classes, unused functions, things like this, unused variables. So that way you can go in and clean them up. Again, the command for that is basically telling it where your source code is. In this case, I'm outputting it as XML. I'm passing the unused code filter and exclude the vendor directory, and I'm telling it where to put the report file. And it looks much the same as the last one, but it's only reporting on things that the unused filtering does. Very important tool, because now you can very easily go in and figure out what is not used anymore. The alternative would be opening up a file in an IDE within a project and it tells you things aren't used, right? But usually that's only limited to a file. This is going to tell you whether it's unused throughout your whole application. And it's makes it very easy to clean things up. We also have a PHP dead code detector. This looks in your code to see code that is dead. It's kind of a duplicate of the unused, but occasionally I get new things in this report, so that's why I run it. But again, it's going to show you unused things. Another tool that I really like to use is PHP Metrics. You can find this at phpmetrics.org. And I think there's even a new way to install it from when I put these slides up, so don't just ignore that. And they've actually refactored this. It works a lot differently now. It used to give you one HTML file as your output with all the CSS and everything in it. Now it actually gives you a website with an index file and CSS and everything as part of it. But it does give a lot of good usable output. It gives you graphical representations of your objects. It gives you a star graph showing how things relate to each other. It's really a good usable tool. Sometimes it's better to see things in a snapshot, which this does really well as far as graphs and things, and can help you nail those down a lot quicker. Now, another tool that I use quite often is PHP Code Sniffer. Anybody using PHP Code Sniffer on a regular basis? Okay, I see some hands. There's some good hands there. That's awesome. PHP Code Sniffer is nice. I'm a little bit dismayed with version 3, so I usually use 2.9 right now because version 3 is still a little bit unstable in my opinion. But that being said, it's great. It's great to have those sniffs that you can apply to your code. Sniffs meaning it's looking for code smells, right? So you're looking for code smells, and then based on the code smells that you get, you can follow up. I usually run this I can run it in the IDE. I don't turn it on all the time because I don't want it to be sniffing my code as I'm programming because I'm not done yet. Of course there's a smell there, right? I don't need it to tell me that in real time. It can be a pain in the butt. But I do run it after I finish something because I want to see, did I miss something, right? Do I need to go clean up something? Or I will run it from my source control. Before I'm doing a commit, I'll have it fire off Code Sniffer to sniff the code, and if there's anything comes back, it doesn't allow me to do the code based on certain sniffs, right? And that's one way to make sure that the developers on your team are committing good code and doing things of high quality. So in today's modern age, if it's good to run these tools, it's ultimately gooder to put them in a container, right? So that's what I did. I wanted to run these tools, and I wanted to make it easy to run them. I wanted to make it easier for my customers to run them. And so I created an image out on Docker, and you can find them on my hub.docker.com. Adam Culp, I'm Adam Culp there as well as most other places, and I created some Docker images that contain all these tools, so you can just tell Docker run and give it the commands that I had up here, and it runs the tool. So you don't have to worry about downloading it on your local machine. You can run it through a Docker instance, and it'll output the file. It's nice and easy to use. And again, you can find that out on my Docker Hub. It's got full documentation on how to use it and everything else. One that I have as an add-on there, though, it's a little bit troublesome, and I'm trying to get it fixed. I'm working with some friends of mine to get it fixed. There's also one that I use as PHP Compatibility. PHP Compatibility allows you to test your code using Code Sniffer to see if it's compatible with all the versions of PHP up to 7.1. It's up to 7.1 now. It's a little bit problematic though because they're refactoring it. Wim Godin is the original author of it, but there's a few people actually working on it now to clean it up because it's not working really well with the current Code Sniffer. Code Sniffer doesn't really like the naming convention that Composer passes through. Composer does them as lowercase, and the XML shows the name of the PHP compatibility as upper and lowercase, and it doesn't work real well. But they're figuring that out. There's also some commercial tools out there, like Code Climate, where it gives you back a score on your code. You can automate these as well, so you can have it check your code, or something like Scrutinizer is another good one to use to run on your code real time. So as you're doing commits, as you're doing things, it can output the statistics and help you. There's other ways to measure your code, like using some toolbars. And I work at RogueWave. We have Zen Server, and Zen Server has Z-Ray that is a little toolbar, and it gives you back all your queries. It'll tell you a little bit more about your code quality as you're going in real time. Most developers, as we develop, we're coding, and then we go back to the browser and refresh, and then we go back and code, then we refresh again. Z-Ray makes it easy to get some of that information real usable. Another tool that I use pretty often is Apache Bench. Anybody using Apache Bench? Yep, good. Apache Bench allows you to check the speed of your site, right? It allows you to say, mock up some traffic and send it to your site and get back some reports. In this case, I'm hitting a website and telling it to do it for 10 seconds. Hit it as many times as you can for 10 seconds, and then output the report to tell me how many times per second you were able to hit it. And I already talked about Z-Ray. I don't know why I had that one twice. So, in conclusion, we want to make sure that we're measuring everything. As you're running these tools, we want to measure everything. You should be doing it often. You should be doing it constantly, always measuring the quality of your code. If you're not constantly measuring, you might miss something. And don't fear the results. Share them. You know, when you're running the results of the tool, share them with your teams. Share them with your company. If you're not sharing it with your company, they're not going to know that you need to be given extra time to fix some of these things, right? So be open about it. It's not a bad thing. It's not something to be ashamed about. Unless it's really bad, then you should be ashamed because you created it. But that being said, don't be ashamed of it. Show everybody and say, hey, look, we need to fix these things. Give me more time to do it, or give me more time on the projects. Reduce the complexity of your applications. And these tools help do that because they're going to give you insights into how you can make the code better quality, which means it's less complex, generally speaking. Leave code cleaner than you found it. When you're coding and you finish up, or when you're adding new features and functionalities, clean something up while you're there. If you notice that it can be done. If it's something small, just go ahead and do it. Learn to smell problems. Learn to use different tools to smell the code smells. Refactor things and clean in little increments. And learn to love iteration. That's all I have. I do have some resources, though. Again, the link out there on GitHub for Exacat, as well as PHP Metrics. I have PHP-code-quality on my GitHub repo. That is the Docker image, as well as it's available on Hub, so you can do it automated. At Zen.com, we have a lot of documentation on how to measure your applications and how to create cleaner code. We also have some repositories out there to help use some of the different tools that I was talking about. So check that out on GitHub and through Zen.com. A lot of freely available information out there to help folks. If you wanted to find out some more, I do also talk about some of these tools on my blog at geekyboy.com. I talk about them on my podcast occasionally at Run Geek Radio, where I talk a little bit about running and a lot about PHP-related stuff. And if you have any questions or just want to say thank you, just tweet to me at Adam Culp on Twitter. Thank you. Any questions? No? Okay. Go. There are a couple. All right.
It's coming.
Okay, thanks. Okay, so because there's a lot of tools here to run, my question is it too late to run all this during CI and Jenkins, or should we be running this constantly locally?
That's a very good question. So I generally run these tools as part of my Jenkins. So as I'm doing the deployment. Now, that doesn't mean I'm going to fail the build based on the output of these reports. I generally don't. I will fail a build for PHP unit failures. I will fail a build for certain other things. But I'm not going to fail a build for PHP Mess Detector. I'm not going to fail it for some of the other tools that I named. But I do run all of them in my pipelines. But I have them output to text files, so then I can go back and read them afterwards and see who messed up the code. And I know it's in production, but I want to see who messed it up. What do I need to schedule to be cleaned up later, right? So yeah, that's a very good point. Always include it in your pipelines in Jenkins or any other CI that you're using. Run those as part of your thing, and then that way you have the text files and the reports to analyze later. Yeah.
Thank you.
Any more questions?
Anyone else? I saw a couple hands over here, I thought. There we go.
Well, this one is from the Java world, but they have PHP plugin and JavaScript plugin. So what's your take on SonarQube?
On
SonarQube, have you used it or?
I've not.
Okay, so it can be set up as a part of the continuous integration pipeline.
Cool.
It compares every branch to the master.
Okay.
And if there are any new smells or bugs or vulnerabilities, so it has categories, it just tells you how well are you compared to the master that you were starting from.
Very nice.
So
There are a lot of tools, and like I said, on that link on the top at Exacat, there's a link of close to 100 of them. I can't possibly cover them all in a talk, right? But there's tons of them there. Check them out. There's some that are better than others. There's some new ones there that I haven't had a chance to learn. That they may be better than the ones I'm talking about, right? I just haven't got that far yet because, like I said, there's hundreds of them, and there's new ones, it seems, every month. One of the ones that Rasmus talked about yesterday was Fan, and I recommend that one. That one's really good for finding out if your PHP is compatible with other versions, if your code's compatible with versions of PHP, and it also does some other static analysis as well. I use that one, and one of the containers that I have on hub.docker, you'll notice that I have multiple images there. One of the images is the QA tools that I showed here, and some others. I also have another Docker image out there that you can freely use that includes 3 different tools to check your code against versions of PHP. So you can very quickly look at your application and say, okay, I can move to PHP 7.1 or 7 or even 7.2. Not quite 7.2 yet, but it's getting there. But anyway, so yeah, check those out, and they're easy to use. There's documentation as part of it in the README file that helps you use them. It's a lot easier to do it from a container than it is to do it on your local system. Anything else? No? I don't see any hands. Well, thank you.